A very good morning and a cool welcome to you, dear students, to your geography class. Today we will continue our lesson, chapter number 3, Tides, part 2. Now in the previous class we learnt about the types of tides, centrifugal force and gravitational force. Well, today we are going to learn and watch new tides and learn how these tides are caused and the types of tides. Also, we will see the mighty and destructive tsunami waves. Here you can see in the picture at the back. This is a big, huge tsunami wave. It's very destructive. These are huge killer waves, very big waves, which are having a very big height. The height is in hundreds. The height is. So we will see all this in the video and explanation also. So let's go ahead. Let's ride on these waves. Now, how do these tides work? Do you know, children? How do these tides work? You all must be wondering about this, right? As the timing of the tides varies every day, the range of a tide also keeps on changing. Tidal range is the height and the difference between the high tide and the low tide. Now, there are two types of tides. One is spring tides, second is neap tides. I'll repeat. Spring tides and neap tides. Now I have called Dr. Rob Brander. He is a professor from the University of New South Wales, Australia. He will show you about it. So let's find out in this video.
I'm Dr. Rob Brander, and I'm a surf scientist from the University of New South Wales. And in this episode, we're going to look at a different type of wave, and believe it or not, that wave is actually the tide. Now, the tide comes up, and you can see the high tide mark, and it goes back down the beach, and you can see it's low tide now, and it does that every single day. The tide is a wave. High tide is the crest, low tide is the trough. So there's a lot of water moving up and down the beach, and we need to know what is forcing that water. And there's two other things about the tide that are interesting. One is that the timing of the tide changes every day. High tide today is going to be different than high tide tomorrow. And the other thing is the amount that the tide goes up and down also changes every day. So why is that happening? Now, the timing of the tide is all about the relationship between the Earth and the Moon. So the Earth is pretty big and the Moon is pretty small. But the Moon is big enough to exert a gravitational force on the Earth. And that causes the water on the Earth to bulge up towards the Moon. Now, if you were standing somewhere on the Earth, remember, the Earth is rotating around. And what happens is you would experience two of those bulges each day. And that means that you'd have two high tides and two low tides every day. The other thing to remember is that as the Earth is rotating at a certain speed, the Moon is also orbiting around the Earth. And it orbits at a different speed, and there's a lag of 50 minutes between the two. So the high tide every day is 50 minutes later, and the low tide every day is 50 minutes later, because of the difference in the Earth's rotation and the Moon orbiting around the Earth. Tide range is the vertical elevation difference between the water level at high tide and the water level at low tide. The reason it changes every day not only is related to the Earth and the Moon, but now the Sun as well. Now, remember that the Earth and the Moon both orbit around the Sun, and sometimes the Sun and the Moon are lined up so that their gravitational forces act together and cause a greater tidal bulge on the Earth, and that creates bigger tides, which we call spring tides. Now, when the Moon and the Sun are at right angles to each other, their gravitational forces cancel each other out, and we get smaller tides, and we call those neap tides. So every 2 weeks we get really big tides called springs, and every 2 weeks we get smaller tides called neap tides. You may have heard of something called a king tide, and a lot of people think that king tide is a dangerous sudden surge of water. Well, it's not. A king tide is just a bigger tide. In fact, it's a bigger spring tide, because sometimes the Moon and the Sun are particularly close to the Earth, And when that happens, which is 2 times a year, your tides are going to be bigger. So they're nothing to worry about, they're totally predictable, and they're not dangerous at all. Well, we've just talked about what tides are and some of the characteristics of tides that you might find on beaches. But what we'll do in the next episode of Science on the Surf is something different. We're going to actually focus on the different types of beaches and how they behave.
So students, you have seen this very interesting video, right, of how the tides are formed, and you have learned about the 2 types of tides also. So let's go ahead now. I will tell you about the 2 types of tides. Types of tides. The first one is the spring tide. Now on a new moon and full moon days, the gravitational pull of the sun and the moon act in the same direction. Now you can see here the gravitational pull. This is the gravitational pull over here, and gravitational pull is in the same direction. So the bulge is over here. You can see the bulge here and here. Here it is low. Here both the sides, opposite sides, is bigger. This creates a bulge rise in the water level. This is called as spring tide. Spring tide is also known as high tide. Okay, look at over here also. You can see the moon when there's full moon and when there's new moon and full moon. It's all in the same direction. Okay, and the bulges over here. The bulges over there. You can see the bulges. This is a lunar tide and this is solar tide. Okay. Now we'll go to the next one, which is the Neap tide. While the moon revolves around the earth, it makes a right angle with respect to the earth and the sun twice a month. The forces of both the sun and the moon operate at right angles on the earth. See this pic. You see right angle. Now, you know the moon is going round and round around the earth, right? So when it forms an angle of 90 degrees, the bulge is over here. Wherever the moon is there, the bulge is over there. Here high tide, here high tide. So opposite will be low tide, low tide. Here you can see the level of the tide. Okay. Now you see it in this picture also. This is the sun, this is the moon, and this is the earth. Now when it is at the right angle, that is 90 degrees, you can see the tide is, the bulge of the tide is higher on these sides and lower on these sides. These are called as neap tides. What they are called as, children? Neap tides. And neap tides are also called as low tides. See, wherever is here is low tide, low tide, low tide. So these low tides are called as neap tides. The neap tides are little lower than the average high tides and a little higher than the average low tides. There's not much difference, but there is some difference. Next one, will you see the explanation for part 2. In this we will learn about the types of tides, spring tide, neap tide, and the difference between them. You will see the difference between them. Watch closely.
Yes. Today we will go ahead with the second part of our third chapter, tides. In the first part, we learned as to how tides occur, what are tides called, and its duration. What are we going to learn in our second part? Okay. In our first part, we learned about the high tides and the low tides. Tides when the water level is closest to the coast. High tide when it is far away from the coast, it is the low tide. So today we are going to learn about the different types of tides. Okay. So types of tides. Now how are these tides classified? As the timing of tide varies every day, the range of the tide also keeps on changing. As I have told you, the time varies. Suppose if it is high tide at 9 o'clock in the morning, so the second high tide will be after 12 hours 25 minutes. Yes, and then again after 12 hours 25 minutes again. So within a day, you will have a cycle of high tide and low tide. So the time varies, and also the range of tide also keeps on changing. Range means it with what velocity, with what speed the tide is there. Okay. Then on a full moon day and new moon day, the highest high tide occurs. Yes. And on the days of the first quarter and third quarter, the high tide is at its minimum. So what happens to the high tides on the full moon day and a new moon day? Yes. So that is on the day of Purnima and the day of Amavasya, the highest high tide occurs on these 2 days. The high tide is at its highest level, whereas on the days of the first quarter and the third quarter, the high tide is at its minimum. The first quarter will come after the new moon day and the third quarter will come after the full moon day. So on these 2 days, the high tide will be at its minimum. Yes, so the level of water rising will be lower than the average high tide, and on the full moon day and new moon day, the level of water rising will be higher than the average high tide. So how is this occurring, and what are these tides called as? So these types of tides are, the first one is the spring tide and the second one is the neap tide. So first we will learn about spring tide. What are spring tides? On a new moon day and a full moon day, the gravitational pull of the sun and the moon act in the same direction. As we have learnt earlier that on the new moon day and the full moon day, the sun, the earth and the moon, they are in a line. Yes. So since they are in a line, and we have also learnt about the gravitational pull of the moon and the sun as well. So since they are in a line and they act in the same direction, the pull of the sun and the moon is also in the same direction. So what happens as a result of this? As a result of this, the total pull increases. Since the total gravitational pull is from one side, that of the sun and the moon, so the total pull also increases. Now since this total pull increases, the water level rises. Yes, so double the pull, so the water level will also rise, and the tides on these days are much higher than the average high tide. So because of the gravitational pull of the moon and the sun, the water is pulled. So it means it comes closer to the coast and it is higher compared to the other average high tides. So that is on the full moon day and the new moon day, the high tide will be at its highest compared to the other days. Got it, children? So on the new moon day and the full moon day, the tides will be at its, the high tide will be at its highest compared to the other average high tide. Fine. So these tides are called spring tides. What are spring tides? Spring tides occur on the new moon day and full moon day. On this day, the sun, the moon's gravitational force acts in the same direction. Since it acts in the same direction, the total pull increases. When you pull something in one direction, so the power is more. So this pull increases, and as a result of this, the tides which occurs on these days, high tides which occurs on these days, are higher than the average high tide. And these tides are called as spring tides. Spring tides occur on the new moon day and full moon day. Fine. Here we have a picture over here. See, we can see over here. Yes, you can see over here. This is the sun over here. The moon is here, and we have the earth over here. So they are in a straight line, isn't it? And what happens? The gravitational pull of the sun, the gravitational pull of the moon, they act in the same direction. So since it is acting in the same direction, the water level rises. So we have high tide over here and we have high tide over here also on the opposite side. Yes, so this is on the new moon day and the full moon day. Got it, children? Fine. As the bulge at the high tide is greater, the water at the low tide recedes much more, and the water level during spring tide is higher than the average high tides and lower than the average low tides. Now, what is as the bulge at the high tide is greater, the water at the low tide recedes much more. Okay, now see this level, this bulge over here. Yes, it is greater, isn't it? And see the low tide. Yes, it is very small. So the water, as the high tide is greater, the low tide will be very small. The water level of during the low tide will be lesser compared to the average low tide. Because of the gravitational pull of the sun and the moon, the high tide is higher than the compared to the other average high tides. So the water level during spring tide is higher than the average high tides, and at places where there is low tide, the water level will be lower than the average low tides. Are you getting me? I'll repeat once again. Spring tides occur on the full moon day and new moon day. On these days, the gravitational pull of the sun and moon act in the same direction. Yes, and as a result of this, the total pull increases. Since the total pull increases, the water level rises higher than the average high tides. So these tides are called as spring tides. What happens during spring tides? As the bulge is higher at the high tide is greater, as we see in this picture over here, the water in low tide recedes. So high tide, more high tide, so the low tide, places where there is low tide, the water level will be lesser compared to the other days, and high tides will be higher compared to the other average high tides. Is this clear, children, about spring tides? Very good. We'll go ahead. Neap tides. We learned about spring tides. Now we'll be learning about neap tides. What are neap tides? While revolving around the earth, the moon makes a right angle with respect to the earth and the sun twice a month. Isn't it? So the first quarter and that is the first quarter and the third quarter. On the new moon day and the full moon day, they are in a straight line. Yes. While in the first and the third quarter, they make a right angle in respect the earth, the sun and the moon make a right angle to each other twice a month. It is 2 times, twice a month. That is the first quarter and the third quarter. This position occurs on the first and the third quarter of each month. Fine. On both these days, the forces of the sun and the moon operate at right angles on the earth. So, on the first quarter and the third quarter, during that period, since they are in a right angle, so their forces, the force of the sun will act through the right angle, and the gravitational force of the moon will act also in the right angle. So, from 2 different directions, they will be acting. So, since they are acting from 2 different directions, their power will be lesser as compared, the power of the pull will be less as compared to that of the spring tides. Yes. So, what happens? Due to such conditions, the water level rise is less than usual at the time of high tide. So, only from one side the sun is pulling and from one side the moon is pulling. So, that is why the water level which rise will be lesser as compared to the usual time of the high tide. And fall in water level is less than the usual at the time of the low tide. So the water level during the low tide will also be lesser. Yes, it will not be more. There will not be more water fall in the water level. The water level will fall very less during low tide. And this happens because the sun and the moon are in right angles to each other, and such tides are called as neap tides. Okay, so neap tides occurs on the first and the third quarter of the month. This is twice a month. It happens when they are at the right angles, and as a result of this, since the sun, the moon, and the earth are at right angles, their forces act in 2 different directions. Okay, because since they are acting in 2 different directions, the water level which rises is less. The water level which rises during the high tide is less than the usual time of high tide, and the water level which falls is also less during the low tide. And this happens because the sun and the moon are at right angles to each other. And the tides which occurs on these days are called as neap tides. What are they called as? Neap tides. You will understand it better through this diagram. Okay. Over here we can see. Okay, this is the sun over here we have. The moon is here. And we have the earth over here. Okay. Now they have formed a right angle. See. Right angle means 90 degrees. Isn't it? You have learnt about it. 90 degrees. So the sun's pull will be from this side. The moon's pull will be from this side. Yes. So since the moon's pull is stronger than that of the sun, we will be having a high tide over here. Okay. I'll show you again. Okay. The sun's pull will be from this side. The moon's pull will be from this side. Since the moon is closer to the earth, its pull will be stronger than the sun. So we will be having high tide over here. And on the opposite side also there will be a high tide. And from the direction where the sun's gravitational pull is there, it will be low tide. Yes, so this also will be low tide. Got it, children? So now what is the difference over here? Because it is at a right angle. The sun and the moon are at right angles with that of the earth. Okay. Neap tides are little lower than the average high tides and a little higher than the average low tides. Yes, spring tides, what were they? Were higher than the average high tides and lower than the average low tides. Whereas neap tides are little lower than the average high tides and little higher than the average low tides. It's the other way around. That is because of the gravitational force acting in two different directions. Right? You will understand it better when I show you this table. Okay. So over here we have the difference between the spring tide and the neap tide. When does the spring tide occur? It occurs on the new moon day and full moon day. When does the neap tide occur? It occurs on the first and the third quarter of the month. Yes. Second point. What happens on the spring tide? The gravitational pull of the sun and the moon act in the same direction. Since they are in a straight line, they act in the same direction. And what is the position of them during the neap tide? The sun and the moon are at right angles to each other. Yes. So during the spring tide, they are in a straight line, and during the neap tide, they are at right angles to each other. What happens to the tides on spring tide during the full moon day and the new moon day? The tides in these days are much higher than the average high tide and lower than the average low tide. And on neap tide, the tides are a little lower than the average high tide and a little higher than the average low tide. So, comparing these spring tides and neap tides, the tides on spring tides day, the high tides, okay, the high tides is higher compared to the average high tides and lower than the average low tide. Neap tides, the high tides will be lower than the average high tides and the low tides will be higher than the average low tides. That is because of the gravitational pull of the sun and the moon act in two different directions during the first and the third quarter. So those are the neap tides, and the gravitational pull of the sun and the moon act in the same direction during the full moon day and the new moon day. That time we have the spring tides. Is this clear, children? So we have learned, what have we learned today? We have learned about the spring tide and the neap tide. Which days do they occur? How is the position of the sun, the moon and the earth? How is the pull of the sun and the moon? And what level, how the water level rises during the high tide and the low tide. That is what we have learned in today's session. We will be learning ahead again, continuing the part.
Now we will learn about waves, the structure of the waves, velocity of waves, that means the speed of the wave. Then we'll learn about tsunami and how to identify the tsunami and what are the safety rules for tsunami. It's a very interesting, children. Please watch clearly.
In previous parts of the chapter, we have done that what is centrifugal force of the earth and how gravitational forces of the sun and the moon causes tides on the earth. We have also learned that tides are of two types. First, according to the height, that is high tide and low tide, and second one according to the phases of moon, that is spring tide and neap tide. Today we are going to learn about waves. If you blow air over hot milk or tea while drinking, ripples are generated on the milk or the tea. In the same way, because of the force of the wind, water appears to be moving. The sea water gets pushed by the wind and ripples are generated on the water surface. These are called waves. So what are waves? Waves are caused by the frictional drag of the wind over the water. The sea water gets pushed by the wind and ripples are generated on the water surface are called waves. So the sea water moves up and down or slightly forward and backward due to the waves. The waves bring the energy contained in them to the coast. They break in the shallow waters near the coast. Large or small waves are formed continuously at the surface of the sea. Generation of waves is a natural and regularly occurring phenomenon. So what is the structure of the wave? Wave crest, it is the highest part of a wave. Wave trough, it is the lowest part of the wave. Wave height, it is the vertical distance between the trough and the crest of a wave. Wavelength, it is the horizontal distance between the successive crests of a wave. Look at this picture. You can understand the structure of waves. What are crest, what is trough, what is wave height, and what is wavelength. What is wave period? It is the time interval between the passage of successive crests at a stationary point. And wave base is the maximum depth to which waves moves the water, equal about half of the wavelength. Now types of waves. Waves can be constructive one or destructive one. What are constructive waves? Constructive waves are the flat and low in height and have a long wavelength. The strong swash carries material up to the beach, forming a berm. They have a low frequency of between 6 and 8 waves per minute, results in a big backwash. Now look at the destructive waves. What are destructive waves? They are a large wave height and short wavelength. They have a tall breakers that have a high downward force and a strong backwash. Their frequency is high with between 13 and 15 waves per minute. The strong downward energy helps erode beach material and cliffs. The strong backwash results in narrow beach profiles. Wave velocity. It is the speed of the wave. Velocities of normal ocean waves are about 90 km per hour, while tsunami have velocities up to 950 km per hour, about as fast as jet airplanes, and thus move much more rapidly across ocean basins. The velocity of any wave is equal to the wavelength divided by the wave period. What is tsunami? It is a series of waves caused by an earthquake, underwater, volcanic eruption, landslide, or other abrupt disturbance. If you are under tsunami warning, then first protect yourself from an earthquake. Get to high ground as far inland as possible. Be alert to the sign of tsunami, such as the sudden rise or draining of ocean waters. Listen to the emergency info and alerts. Evacuate. Do not wait. And if you are in a boat, go out to sea. How can you identify tsunami? Abnormal ocean activity, a wall of water and an approaching tsunami create a loud roaring sound similar to that of a train or a jet aircraft. If you experience any of these phenomena, don't wait for official evacuation orders. Immediately leave low-lying coastal areas and move to higher ground.
Tsunami safety rules.
So students, today we have done with waves. What are waves? What is the structure of waves? What do you mean by velocity of waves? What do you mean by tsunami? And how can you protect yourself during tsunami? Thank you so much.
So students, you have learned all these things. I hope you have understood very clearly. Now let's look about some little explanation about the structure of the waves. This is the final part of the lesson. Then we'll see the video on the biggest tsunamis in history. So keep watching. Firstly, waves. The sea water gets pushed by the wind and ripples are generated on the water surface. These are called as waves. Okay, these are called as waves. Now let's look at the structure of the wave. The raised up portion of a wave is called crest. See this raised up portion, this is called a crest. The depressed portion of a wave is called a trough. This one, the depressed portion. Crest is the top. The raised up part is called a crest. The depressed portion, which is a curve down, is called a trough. You see one trough is here, one trough is here. The vertical distance, which is the height of a crest and a trough, this vertical distance are called as amplitude of the wave. It's called the amplitude of the wave, the height. There's a vertical distance. Then the distance between two successive crests. The distance between two successive crests, one crest here, and a crest here. Or trough. The distance between troughs or crests are called as wavelength. It's called as wavelength. Okay. Now we come to the last part, the most exciting part, the biggest tsunamis in history. I'm going to show you this biggest tsunamis in history. What are tsunamis? Let me recap. Tsunamis are giant waves caused by earthquakes or volcanic eruptions underneath the sea. Their speed is very fast as jet planes. How jet planes go very fast, like that. A tsunami is a series of ocean waves caused by any large or sudden disturbances of the sea surface. Okay, now let's watch it.
The biggest tsunamis in history. The ocean can be a beautiful and calm place. However, it can become devastating. Today we'll show you some historical success where the sea unfolded all its wrath, becoming tsunamis that destroyed complete cities in just a few seconds. Join us in this almost infernal adventure. 2010 Chile earthquake tsunami. We begin this list with one of the worst contemporary tragedies, because on February 27, 2010, an almost 4-minute earthquake reached a scale of 8.8, causing a devastating tsunami. This ordeal ended the life of 500 people and left 9% of the population homeless. This earthquake was so violent that 53 countries had tsunami alerts. The president at that time, Michel Bachelet, declared a state of emergency and sent rescue troops to every area of the country. The damage caused by this tragedy cost around $4 and $7 million in material losses. Great Yayama Tsunami. Continuing on our list, we name one of the most affected zones by this kind of catastrophe. We are clearly referring to the land of the rising sun, Japan. This disaster happened on April 24, 1771, caused by an earthquake which began in a zone actually known as Okinawa at the south of the country. The magnitude of this tsunami affected the Ishigaki and Miyakojima Islands, where almost 12,000 people died and more than 3,000 were left homeless. Because of how old this event is, the information of this event isn't completely correct. There are legends that say that there is an island that disappeared because of the strength of this tsunami. However, this was never confirmed. Nature's fury was so relentless that the population of those islands reduced by a third. Also, the agricultural landscape was extremely damaged because of the high water levels. 1792 Unzen earthquake and tsunami. A few years after the last tsunami, in 1792 to be exact, another tragedy would hit this Neap country. That date, a volcano known as Mount Unzen erupted, becoming the most lethal volcanic eruption in the whole of Japanese history. To double its mortality, it also caused a mega tsunami that had waves of 33 and 66 feet in height. It's estimated that 15,000 people lost their lives, being Higo and Shimabara City the most affected zones. The volcanic eruption was so strong it made the waves grow up to 187 feet in height. 2011 Tohoku Tsunami. This horrible tsunami happened on March 11, 2011. Everything started with a magnitude 9 earthquake, whose epicenter was the Tohoku region, producing giant waves of approximately 43 feet in height. The huge walls destroyed everything in their path and took the lives of 15,000 people. Although Japan is a country that has constant preventions against earthquakes and tsunamis, they never expected a tragedy of this magnitude. The total amount of damage done was around $350 billion.
This comes to the end of this lesson. I know you have all enjoyed learning this lesson about the different tides and waves and the tsunamis and how it is caused. Okay, thank you very much.